Alright, this is the second part of the 1.3.1 homework video. Doing the same things. I'm going to assign these values over here, ones and zeros, in all the possible ways. I don't know why I'm wasting my time. I should just copy them from over here, right? And those are the possible ways that this can go down. Right? All the ones, 4 ones, 4 zeros, 1 1 0 0, 1 0 1 0, right? Just like that, like we did before. And now I'll look at my premises and I'll apply rules. Now remember, we're working inside out, right? If P, then Q and R. And I need to know, in order to apply the if-then rule right here, I need to know if P is true and Q and R is false. But Q and R I haven't decided yet, so I have to do this column first before I can do the if-then column. And I look at my AND rule, and my AND rule says A and B is true if both A and B equal 1. If A equals B equals 1, right? So if both of them equal 1, then A and B equals 1. Otherwise, it's 0. So I'm going to put 1s every time Q and R both have 1s. And there you see Q and R both have 1s, so true. And right here, Q and R both have 1s, true. The rest of the time, it's false. 0 0 0 0 0 0. Alright, now I'll look at, again, my Brenthiana. Oops, that's not, I wanted to highlight. Alright, now I'll be looking at my Brenthiana here, and my Brenthiana here. And I'll be saying, whenever the P is true and the Q and R is false, then the if-then is false, right? So here's one case, P is true, Q and R is false, so this is false. Again, P is true, Q and R is false, false. P is true, Q and R is false, false. And the rest of these are true. Now the not rule is super easy, right? Not A is true if A is false. Otherwise, not A is false, right? So if A is true, then not A is false. So every time, so this just flips them around, right? Not R, because, R is 1, not R is 0. If R is true, not R is false. If R is false, not R is true, right? So that's all you're going to do. Just flip them around. There's that. And same thing here. Oh, can't connect. Alright, so now here are the columns that I'm worried about. I'll once again highlight them in yellow. I'm looking at the not columns here. I don't care if R is true or false. I want to know, is not R true or false? Alright. Yeah, so those are the ones I'm worried about, and I'm looking for whenever the premises are true and the conclusion, both premises are true, can the conclusion be false? Now here I see a premise is false, so I don't worry about this one. Here I see 3 times that the premise is false, so all 3 times. I'm not even paying attention. Here's a premise false, here's a premise false, so let's hook that up. There's only there are only 2 times that the premises are true, right here and here and here and here, and both of those times the conclusion is also true, so this is valid. And if you look at it, it says if P, then Q and R. If you have P, then you have Q and R, right? You have, in other words, if you have P, then you have both Q and R, but you don't have R. So if you don't have R, you don't have Q and R, right? You have to have Q and R in order to have Q and R, but you don't have one of them. So if you don't have Q and R, that's not Q and R, right? So that means you can't have P. This says if you have P, you have to have Q and R. We just said we didn't have Q and R, so that means we can't have P, and that's what this says over here. So this is valid. All right, let's do 4. Now 4 and 5 are cases where you have no premises, you just have a conclusion. So you're looking at this and you're saying, is the conclusion just always true? If the conclusion is always true, then this is valid. Otherwise, it's invalid. So my assignment's going to look a little different. P can be either be true or false. If P, if P is true, Q can be true or false. If P is false, Q can be true or false. So there you go. Again, working inside out. All right. So if P then Q is false, if ever P is true and Q is false, which is right here, otherwise it's true, true, true. And let's make this an olive, nice olive color. These are the ones I'm worried about now. If P, we're looking at if P then Q, if that is true, then you can't have Q be false for this if then, right? If this thing is true, then this thing must be true too. So if this is true and this is false, then the if then is false. Here is the case where if the first one is true and the second one is false. The antecedent is true and the consequent is false. So this is false. The rest of them are true. And then we'll go back to the burnt sienna. Ooh, blowing up. All right, and these are what I'm worried about now. If P then Q is true and the Q is false, then this whole if then is false, and that is right here. That happens. The rest of the times it is true. And now this is the one I'm worried about. Now this is the one I'm worried about for the whole thing, right? This whole thing is either true or false based on this one right here. So is it ever possible for the conclusion to be false? Because we don't have any premises that are true. Then we're not worried about premises. We're just saying the conclusion is always entailed if the conclusion is always true. But here's a place where the conclusion is not always true, right here, okay? So we have one place where this is not, the conclusion is not true, so this is invalid. Finally, this guy right here, and this value assignment is going to look just like this one that we just did. So I'll assign like that. Again, working inside out, right? So if P then Q, it's only true. It's only false when P is true and Q is false, which is right here. Otherwise, it's true, like so. And then now, when I'm doing this if then right over here, I'm looking at the not P is true and the Q is false. So I have to see when is the not P true or false. And the not rule just flips them around, right? So P is true, then not P is false. P is false, then not P is true, right? So whenever not P is true and Q is false, the if then is false. So here's that case. The rest of them are true. All right. So I'm looking at, I'm looking at this one. There's my olive. There's my olive. And this one. All right. And now I'm worried about the and. Okay. The and is true when both of them are true, and it's false otherwise. Here, this one is true and this one is true, so the and is true. Here, one of them is false, so the and is false. Here, this one is true and this one is true, so the and is true. And here, one of them is false, so the and is false. All right. This is what I'm looking at for the next time. So I'm going to just put that in my burnt sienna, and then I'm going to worry about the second part over here. Now, this whole thing is true, and this whole thing is false, then the if then is false. But we have to know if this whole thing is false, so we're going to have to do the not. So again, that's just flipping the script. All right, and that's the burnt sienna. And now I'm looking when if P then Q and if not P then Q is true, and not Q is false. Right here is that case. And there's another one right here, right, where this is true and this is false. The rest of them are true, right? So this is the one I'm worried about, the whole thing. And sadly, this is also invalid. And let's see. This should make sense. Maybe it doesn't make sense initially, but look, this is saying if you have P, then you have Q. And then it's also saying, and if you have not P, then you're going to have Q, right? So if you have P or you have not P, then you're going to have Q. If you have either one, but you have to have one of those, right? Well, at least in classical logic, I should say. In more advanced logics, oh shoot, sorry, that was loud probably. In more advanced logics, I should say alternate logics. Yeah, not the case that they're more advanced. In alternate logics, you don't have to have one or the other. But in this logic, you have to have one or the other, either P or not P. And so you're going to have Q. But this says if you have this, then you have not Q. Well, that doesn't even make any sense, right? You just said you're going to have Q. So how could you have not Q? So that's why this one is invalid. I will see you tomorrow.